Welcome to the course Introduction to R Programming. In this lecture, I will cover about missing data and logical operators. The outline of this lecture consisting of missing data, logical operators and comparisons, examples, and finally conclusion. Then coming to missing data. R represents missing observations through the data value NA. Here NA means not available. We can detect missing values using the command is.na. For example, here you are assigning NA to a variable x that can be defined as x equal to NA. Then whenever you can call x, the NA is displayed. Now, if you want to check out is there any missing value in x by using the command is.na. So whenever you can type this command is.na of whatever the variable we assigned na here, that is x, which shows it is missing. It gives the result whether it is missing or not. If really it is missing, it gives true, otherwise it gives false. So then you can see whenever you can execute this command, here you will get true. Why you will get true, why not false? The reason is here x you defined na not available, that is empty. So that means x does not contain any value, it contains null. So missing values are there in x. Therefore it gives the result as is.na of x. It gives true. So same you can execute in our R software. So this is the screenshot given here. So we will also try to execute this one. First you can assign x equal to na. So then you can check out whether any missing value is there or not in x by using the command is.na of x. Now move to our R console. So first I am assigning x equal to na. Now what x contains? Na. Na is assigned to x. Now if you want to check out whether any missing data is there in x or not, so you can use the command is.na of the assigned variable name. So here is.na of x. So is there missing? Yes, it is true. Why? Because previously what x contains na, so not available. There is null. Therefore it gives the result as true. So like that, R represents missing observations through the data value na, which means not available. So then coming to, you can try a vector by considering a vector to know if any value is missing. So for example here, let us take a vector with c of 11, na, 13. So these values are combined by using c, and that can be stored in the form of vector. That vector is assigned to the variable x. So now you can check out similar to single value in x. Now what x contains? A vector. So whether any missing value is there in vector or not by using the command is.na of x. So whenever you can execute this command, so it shows one by one with a particular value. It verifies all the values with is.na of x. The first value 11. So 11, that is the value. It is not a na. So there is no missing. So that means it gives false. So if there is missing, then only it displays as true is.na. If something is there other than na, then it gives false. Then na, so na is the missing, so it is available, so true. Third position 13, that is not na, that is the value, so it gives false. So this is the output. So then you can see what x contains. If you want to see, so x11 na 13, like that is.na for a single variable or a vector, you can find any missing value is there or not. Now you can see the demonstration in the screenshot. The executed commands are given. So including previous one, first x equal to na is assigned. So assign na to variable x and is dot na of x, it is missing question mark. Yes, missing is there, true. So then suppose another case, you are taking x equal to 4, second case. So is there missing in x? Is dot na of x? There is no missing. If missing only, it gives true, otherwise false. Why? Because x is not na, x is a value, therefore it gives false. Similarly, latest whatever we discussed, by considering vector x equal to c of 11 comma na comma 13, if we can apply is dot na of x, so it verifies is dot na to each and every value in the vector. First it checks with 11, so 11 is not missing, so it displays false. Then na is missing, so then it displays true. Then 13th is not missing, so it displays false. So like that, each and every value is.na function is applied and the respective result is displayed. Now you can execute all these commands. Will also now previous one as usual. Now you are taking another one. I am taking x equal to some value, suppose 4. Now I am checking is there any missing in x. So what is the output actually? X equal to 4, that is not a na, not available. It is not available, it is available. So then it gives false only. So then you can take a vector, suppose x equal to c of suppose some value, then second value as na. So now you can see this is the direct values. So whenever you can apply is dot here you can see x less than, here we typed wrongly, so the equal symbol is x less than dash symbol. So now you can see the x what contains 10 na 20. Now you can apply the function is dot na of x. What is the output now you can tell? So the first one is dot na of 10. So x contains 10, so there is no na. X contains value, so it displays false, first one. And second one is na, so here missing data is there. Then in second position it gives true. Then third position x is 20, there is no missing value, so it gives false. Whenever you can enter, you can see false, true, false. So like that, we will check the missing data using is.na command by a single variable or by a vector. So then we will see some more examples how to work with missing data. So now try a vector to know if any missing value is missing. This we already seen. X equal to c of 11 comma na comma 13, which is a vector. Suppose if you want to compute some of the functions with the vector data, for example mean of x. So how it will be calculated? Here three values are there. Actually the mean is all the sum of all the elements divided by total number of elements. So here three elements are there. So it takes 11 plus na plus 13 whole divided by 3 actually. But the second position na is missing, so that won't be considered. So we can consider only two values, 11 plus 13 divided by 2. So whenever you can execute this function, so it won't work. The reason is one missing value is there. So any missing value, is there, it won't compute mean. So then it displays only NA. Suppose if you want to remove that missing values, then you need to calculate the mean value. So the command is in the mean function mean of x, comma. So whenever you can give na.rm equal to true. So not available dot rm, that means remove. So this command removes the missing value whenever you can make it as true. So NS can be removed. Then automatically after removing the NA values, it computes mean with other values. That is 11 plus 13 whole divided by 2. So 24 divided by 2, 12. That is the mean value. So without removing the missing value, directly if you can apply main function, so it shows only missing value. So now we will also execute this command as usual. So first you can create x equal to c of, first clear your string, then freshly you can start x equal to c of 11 comma na comma 13, x equal to c of, so first value is 11, second value is missing, third value 13. So if you want to see what x contains, this is the x data. So now whenever you can apply mean of x, so it shows NA, the reason. So mean can be computed for all numerical values, but here one missing value is there. So whenever you can apply mean of that particular variable, it shows only that missing value. So now after removing the missing value, so to compute the main function, in the main function itself, we can write this command na.rm equal to true. So now I am recalling the main function. So x comma na, that is not available dot rm, removing with the condition true true. Now you can see directly the result is displayed here. Like that we will work out with missing data, so using these operations. Then some more points about this missing data. Here you can observe the null object that can be called with uppercase letters null is returned by some functions and expressions. That is the use of null. Here one difference you can observe. The NA and null are not the same. So NA is not available where null is written by some functions and expressions. So NA is placeholder for something that exists but is missing. That is the meaning of NA. Whereas null stands for something that never existed at all. Whenever you can use null, so something that never existed at all. That is the difference between NA and null. So that's all about handling of missing data using our software. Then coming to our next topic, logical operators and comparisons. So here in our mathematics, whatever the logical operators and comparison operators, so we studied the same operations we will use here also, but using our R software, how this can be demonstrated. Before going for demonstration, first we will see the following table shows the operations and functions for logical comparisons. So logical comparison means either true or false. So here true and false are reserved words denoting logical constants. So wherever true or false so occur, you can use capital T or capital F or full form with all our uppercase letters, that is TRUE true or FALSE false. These are reserved words denoting logical constant. The following table shows some of the relational operators and the meaning of each and every operator. So the first column contains operator symbol. The second column contains its meaning, so which is called as execution. The first one is the symbol greater than. The meaning is greater than. The second one greater than equal. Can we read it as greater than or equal? Next symbol less than. Can we read it as less than? Next one less than equal. Can we read it as less than or equal? Then double equal can be read it as exactly equal to. Then this is not equal, the symbol. So can we read it as not equal to. These are all the various relational operator symbols and their execution statement, that is meaning, how to read the symbols. Similarly, you can see the logical operators. So basically we are having the following operators. The first one is AND operator, that is denoted in our software using single ampersand or double ampersand without any space between these two. You can use any operator as for AND operation. Then second one is OR operator, which can be denoted by single line or double line. So which is useful for computing OR. Then another one is also there using not symbol, that can be called as negation. So also called as not. So if you can see some explanation about these logical operators, the sorter form. The sorter form is whenever you can use single ampersand or single or, performs element-wise comparisons in almost the same way as arithmetic operator. Whereas the longer form, you can use double symbols, double ampersand or double or, evaluates left to right examining only the first element of each vector. The evaluation proceeds only until the result is determined. That is the difference. Then the longer form is appropriate for programming control flow and typically preferred in if clauses, that is conditional statement. So the longer form, so preferably used in the programming control flow. So especially in the conditional statement if clauses. So these are all the logical operators and their explanation. Now some more logical operators with true or false combination by considering this as constants. So here we already mentioned true and false are reserved words denoting logical constant. So the left side table first column operator, whatever we mention, those will be treated as the constants. So whenever you can use these terms, so the equivalent results will be displayed. The first one is XOR is the function. You must use brackets. So it gives either or. The meaning is either or. Exclusive operation. This is called as. Then second one is true. So here, whatever the notation we use, we follow the same command. Here is lowercase, true all capitals. So in bracket the name of the variable. So then the meaning of this command is test if x is true. It tests if x is true. Then directly you can use true, all capital letters. So the normal meaning is true. Then false, use all uppercase letters. So it can be written as simply false with lowercase letters. So in the first column, whatever the syntax given, you have to use same notations. The reason R is case sensitive. Compulsory you have to follow the actual syntaxes. Now we will see some examples of all these logical and comparison operators. First, we will see here the like calculator, directly you can type the values, but using these relational operators and logical operators, then you will see the result. The first example here, 8 greater than 7. This is the expression given. So then it checks a logical relational operation. So whether it is true or false, it displays. See, 8 greater than 7, actually it is true. So it displays true. Then second example, 7 less than 5. Here this condition fails. So it won't satisfy. So it displays false. Then directly using relational operators. Then using the logical operators as constant. The first one is true. So 8 less than 6. It checks whether it is true or not. If it is true, it displays true, otherwise false. See, 8 less than 6, it is false. So it displays false. Similarly, anything you can give. Is 8 greater than 6? If you want to check this condition, is true within bracket 8 greater than 6. Yes, this condition is true, so it displays the value true. So you can execute these values using R software. This is the screenshot obtained from R. So we will also execute the same using the relational operators as well as logical operators as constants. So now I can clear our browser. So first you are checking anything you can check with relational operator. 7 less than 8, it is true, whereas 7 greater than 8, it is false. Then 7 equal to 8, see, it is true. Then 7, you can use all operators, not equal to 8, yes, it is true. Then less than, you can take less than or equal also. So less than equal 8. So 7 less than or equal, so less than it satisfies true. Similarly, 7 greater than or equal to 8. So greater than or equal. So like that, all operators you can demonstrate. So it gives false. Then using is true function, is true of or directly also you can give the value. So 7 greater than 8. Here you can see within the command is true, in place of x you can give the direct expression value. Here what we give 7 greater than 8, so it satisfies the condition. Or you can store something in x, suppose x equal to 10, then the command is wrong. So x equal to 10, then is true of x. What it gives here, there is no condition, simply x contains some value. So within, in place of x you can give some conditions, then only it executes whether these are all true or false. Now we can see some of the examples of logical operators. This example you can observe here, x equal to 5 is assigned to x. Then you are checking the condition using AND operator. So the condition is x less than 10 and x greater than 2. The meaning of this command is, so double ampersand means A and D. And first it checks the first condition, x less than 10, that means 5 less than 10, that it is true. Then second condition, x greater than 2, that is 5 greater than 2. So both are true, then true into true using logical AND, it gives true only. So similarly, you can check with OR also. I can execute this command. So here assign x as some value, let us know 5. Then the condition is, so x less than 10, then logical AND, then x, second condition is x greater than 2, x greater than 2. So whenever you can execute this command, it gives the result. First it computes the left hand side part within brackets, x less than 10, whether it is true or false. Then right side of the expression within bracket 5 greater than to true or false. Then it again computes the AND operation. It is not product, logical AND operation, true, true, true. So it gives true only, the logical operation. So this is the output. Similarly, you can check with OR operation also, logical OR. Suppose if you want to check is x less than 10 or x is greater than 5, using OR, is x less than 10 or x is greater than 5. So you can type this command. So here it performs OR operation, the logical OR operation. Suppose here x equal to 5 only we have taken. the condition is x less than 10 or x greater than 5. So here x greater than 5. Now we are using the OR operation, logical OR. Remove the AND symbol and add. So this is the output. First it computes left hand side part expression, then right hand side part expression, then for both of them it applies logical OR operation. Now, similarly, another example, if you want to check if x greater than 10 or x is greater than 5, both conditions greater than, x greater than 10 or x greater than 5, either. So the logical OR operation. So now you can modify the previous one. So the condition is x greater than 10 or x greater than 5. So using the logical OR operation, so it gives the result. So using OR operation, the output is false. So like that, you can check any conditions of the logical operator and or and even not also. So that is negation. So for that, simply you can use the symbol. These are the logical operators and their comparisons. Then one more example also you can test. If x less than 10, using AND operator, x greater than 2, the same thing. So x less than 10 using AND operator. So AND, now the second condition x greater than 2, let us assume. Now you can see. So it gives like a truth table. So in our mathematics, by taking the values true, 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 false, false, true, false, false. So like that, the same thing, but here conditions. Based on the conditions, true or false, then the final result is displayed. Then some more examples. If you want to test if x less than 10 or x greater than 5. So x less than 10 or x greater than 5. Yeah, this we already executed. Then similarly, x greater than 10 or x greater than 5. Yeah, this is also executed already. Yeah, the same thing is repeated here. So then I can see another example by taking two different variables. Here we have taken x equal to 10, y equal to 20. Then checking the following condition. If x equal to 1 and is y equal to 20. So using here single symbols, short form notations. Earlier we used full form. So here x equal to 1 and y equal to 20. So here double equal means exactly equal to. So whether both conditions satisfies, it gives true AND operation. If anyone fails, then it gives false. So then here you can see x equal to 10, it fails. Then y equal to 20, yeah, exactly it is equal. So one false, one true, then it gives false only. Similarly, if x equal to 1 and y is equal to 2, now you can see x equal to 1, y equal to c. This is false. Second one also, both are false. So false and false, you will get false only, like our truth table. Now we will also execute these commands. So by taking two different variables, now I am taking x as 10, then y as 20. Then you can see whether the value is stored in the x or not. What x contains 10, then see y. What y contains 20. Now the condition is the first condition, x equal to 1 and short form of the AND operator ampersand. Then y exactly equal to 20 is the given condition. Now you can see first condition is false, second condition is true. In the logical AND operation, false true. So you will get false only. Similarly, if x equal to 1 and y equal to 2, here you can observe both are false. So false and false. So you will get false only. So like that, we will check various logical operators with the comparison operators. Like that, you can practice different values. So that's all about this lecture, missing data and logical operators. So then, while coming to conclusion, so here first we have started a discussion on logical operator, and in the next lecture, so I will try to continue with some more examples, with some more explanation. And in the meantime, I will request you try to take some examples from the books or from the assignment and try to practice them. So till then, goodbye, happy learning.